Good morning, everybody. My name is Joe Kelly, as I just mentioned, and today we're going to be going over Introduction to EMC Storage Essentials. So if you're probably like me at some point in your career, whatever vendor you're looking at from a storage perspective, there is a plethora of options, whether it's from a product perspective, whether it's from a software suite perspective, so many different options, and sometimes if you're not exposed to that on a day-to-day basis, it can be quite overwhelming. So the goal of this webinar and as far as further education, the goal of the course, EMC Storage Essentials, which TrainSignal released I guess about 45 days ago, is to expose the audience, expose you guys to all the different components that make up a storage environment. And what I love about this course, and when TrainSignal first started talking to me about it, was it's not only specific to EMC, but it also touches on other areas in the data center from a storage perspective. So we talk about data center protocols, fiber channel, iSCSI, FCOE, stuff that's very specific to storage, but less so specific to EMC. So hopefully as part of this webinar, you'll get a glimpse into what the broader course will provide to you guys. And I encourage you very much to ask questions here as part of this webinar today. I enjoy the interaction. I know you guys have some questions, and certainly don't hold back on this. You know, just go ahead and blast away and let me know any questions because I've got such a broad experience in EMC storage that I think I can certainly move you in the right direction if you're a little bit out of whack right now. So again, my name is Joe Kelly. This is Introduction to EMC Storage Essentials. So who am I? I'm your instructor today. I'm also your instructor on the Storage Essentials course from TrainSignal. I am a data center practice lead. I work for a company called Varrow. We're a value-added reseller out of the Carolinas, North and South Carolina, some in Virginia. Been with them for about 5+ years, so I've seen a ton of environments. We push primarily EMC products, Cisco, VMware products, and I've had the whole gamut of experience with those kind of three core vendor technologies. So, broad experience. I've seen a lot of different things, experienced a lot of different technologies, met a lot of great people, and I hope to bring that to the webinar today. I'm also an EMC proven professional, a VMware vExpert, and an EMC elect. The last two I'm especially proud of because they are community-based designations. The first one, the Proven Professional, is one I wanted to mention real quick as I kind of structured this course around preparing you guys for the entry-level certification that EMC provides. So keep that in mind when you're going through this, and we'll go over some of the goals of the course as well. But think about that when you're looking at these webinars and these videos and this course in particular, that you're beginning to prepare yourself for certification on the EMC Proven Professional path. But also, what's another great thing about this course is that it does prepare you for storage-centric conversations, storage-centric expertise outside of the EMC realm. So the goal of the course, quickly, we'll get into the meat of the webinar here in just a sec. Just wanted to go over some of the goals of the course. Is to really navigate the broad portfolio of the EMC mid-range products and software suites. Now this particularly pertains to the VNX side of the house. So there's not any information on the symmetrics or the lower end of the higher end arrays within the EMC product line. It is focused purely on the VNX itself. Another big goal of this course is to help viewers of this course to be able to communicate and understand common storage terminology, and like I said, not only applicable to EMC, but third-party arrays as well, third-party technologies as well. To me, that is hugely beneficial because I think over several years, and this has gone on forever, so most things have gotten to the point where they become siloed within your environments, meaning you have your network teams and your server admin teams and your storage teams, and we all know that for the better of the business, things are going to be much more efficient if we're able to communicate across those silos, so to speak. So just by listening to these webinars and listening to courses on storage, even though you may be a network guy, is going to better help those communications and efficiencies within the environment and help your business grow. So to me, that's hugely important. I want to know the networking side, but I don't need to be an expert on it. I want to know the server side, but I don't need to be an expert on it. Certainly I have things that I'm passionate about, and as do all you. So the goal, that's one of the main goals of the course, is just better communication across individuals within your team. Also, I want you guys to understand the topology of common storage environments, right? This is what I'll focus on kind of in the first maybe 15 minutes of this webinar, is that we'll take lesson 1 from the course and we'll focus on the 3 core of a common storage environment, is what I like to call it. And then last but not least, this will be supplemental learning for the E10001 EMC Proving Professional certification through EMC. So if you want to move on to any specialties within EMC itself, meaning if you want to focus on Symmetrics or VMX or Recover Point, any of their product lines, you have to take this certification first to specialize. So this is supplemental. There's a wealth of information within this exam that you need to know. And certainly we haven't touched on everything within this course, but it does start the path to learning. And just a quick note on the lessons presented within the course itself. First off, as I mentioned, the common storage environments. We'll touch on that lesson, kind of a brief summary of that lesson here today. Also today we'll focus on the introduction to the VNX series lesson as well. So we'll go over some of the the array models and the software suites. And then outside of that, VNX physical architecture, there is a block and a file side, which we'll get into. Common VNX terminology. With any product, there's always a wealth of acronyms and geek speak, so to say, and we'll focus on those as well in that lesson. VNX software, whether it's management or operating environment, which is what OE is. And then we'll get into stuff that's very applicable to things outside of EMC, not only EMC, but outside of EMC. So storage networks and common data center protocols. And then we'll focus on block protocols, your FC, your iSCSI, your fiber channel or Ethernet. By the way, FC is fiber channel. Then we'll get into file protocols, CIFS and NFS basics. And the last 4 here, measuring performance, measuring availability, workload profiles, and application mapping, and the importance of cache and flash drive, which is hugely making a shift in our industry from a storage perspective that we'll go over. So that's the course in a nutshell. We will get in now to the first lesson here. So I love to start at square one, because I don't want to assume, and the purpose of the course, when we started at lesson 1, we didn't want to assume that you guys knew what fiber channel switches were, you knew what FCOE switches were, you knew what a storage array, intelligent storage array was. We wanted to assume that really you're coming into a storage environment or into this course, and you know nothing. I think most of you probably on the webinar are viewing this webinar because maybe you know just enough about the host side in this example. Maybe you're on the server administration side, or maybe you know about the switches in between, or maybe you know about storage and you just want a little more information on the EMC perspective. But a lot of people nowadays are expected to know all of these components. And if you're mapping these individual 3 core for motion storage environments to maybe to a position or whatnot within your company, you could say that the host side of these storage environments is more catered to the server admins. Switches would be your networking team, and storage arrays would be your storage admins or your storage engineering team. So if we're looking at this and these 3 pillars here, we'll start at the top. So you have your hosts, and we'll go over some of these and more specific examples from a host perspective here in forthcoming slides. But if you're looking at the top here of your host perspective, you have typically a rack server or a blade server, and it has compute, so it has memory and CPU. It also has I/O modules, so the ability to move data in and out of that host. And usually is some HBAs, which are host bus adapters, that attach to some switches, or it could be network interface cards, right? What everybody's familiar with. It could be attaching to an IP switch, or it could be FCOE. It could be some CNA, some converged network adapters, which means it's attaching to an FCOE switch. So whatever means that this host is connecting to the switches, that's represented here within section 1. Then as we move within the fabric A, fabric B, the 3 numbering here, that's when you move into your switches from a generic perspective. Now, depending on how that host is connecting to those switches, really depends on what those switches are. So if that host in particular has host bus adapters, then it's speaking over the protocol fiber channel. And then therefore those switches are fiber channel switches. And if those switches in particular are IP switches, those hosts would have network interface cards or NICs. And they're talking, if from a storage perspective, they're talking iSCSI. And then so on and so forth. So the switching component is somewhat straightforward. The host is probably what you guys are most familiar with. And then to really get into what the meat of the course is the storage array. So the storage array from this example would be the VNX. It's what's represented here is a bunch of disks and a big monolithic type box here. And you have your SPs sitting there, which are your storage processors. Now we'll get into a little bit of what those are. The course goes into it a little deeper. But your SPs in the simplest form are really big intelligent RAID controllers. Okay, so if we're looking at this, they're basically controlling input and output from the front end. And so they're talking specific data center protocols such as iSCSI or FCOE or fiber channel, and they're taking the data that's being fed to them from the host down to the switches and basically dumping that on the back end to physical spindles. Okay, so that's kind of the core of most storage environments. There's a lot to be interpreted from a host perspective, switch perspective, and storage array perspective, but if I could throw up one graphic and show all the different components, this is it right here, and that was the intent of that. Now if we move a little further into this, let's talk about the top tier there, which are the hosts. These are commonly referred to as compute, so it has your CPU and your memory in there, and they provide logic and computational resources to your applications. Now these guys can be both physical and virtual, and we'll go over some of those distinctions here in just a second. I've got represented below just rack servers, but you could certainly throw blade servers in there as well. And that brings me to the next slide. So we have our rack servers. Now sometimes rack servers, for the most part, are larger in stature, meaning they take up more rack space. Not always, but if you're looking at it in comparison to a blade server, not the chassis that the blade server usually lives in, but rack servers usually are larger in stature, they require more rack space, and they're autonomous in nature. So what does that mean? That means when you're racking up a server, and typically if it's not a blade server, that rack server is going to be allocated to a particular application. Now take virtualization out of this, and you can take that comment for what it's worth. You throw virtualization on there, things change a bit. From a blade server perspective, these guys are usually smaller in stature, and on a per blade basis, you can have multiple blades within the chassis itself, and the chassis is really the wrapper for the blade servers or multiple blade servers. And these guys are really dependent in nature, meaning that the chassis itself is providing a bunch of I/O type avenues for those blade servers to talk, whether it's for storage, whether it's for just common network communication on the network. It's all provided within the chassis itself. So usually a blade server cannot operate by itself. A rack server can operate by itself. It's autonomous in nature. What about the physical and virtual distinctions? So I think most of us nowadays, anybody in IT knows that what a physical host is, what a virtual host is. But just to kind of recap on that, a physical host is typically a one-to-one application mapping. So you've got a rack server or a blade server sitting there, and you're putting an OS on it, whether it's Windows, Linux, whatever, pick your flavor, and then you're installing a single application on it. And of course, over the years, that's been highly inefficient. We all know that, and we know that virtualization has kind of turned that on its ear. The resources, your CPU, memory, I/O cards, are captive to that single application, captive to that physical host. Bring virtualization into this. Your virtual hosts are still typically, if we're looking at it from a VM perspective, which is what I'm trying to establish with the name virtual host. If you're looking at it from that perspective, it's typically still a one-to-one application mapping However, the resources, CPU, memory, I/O cards, are shared between all of those applications. So you have a thin layer of software that's controlling access to your underlying resources, and therefore you can stack multiple virtual hosts or VMs across that single physical host. If we move into the second tier there, which is the switches, these are what I like to call the conduit or highway between your host and where your data lives. Now these can be both physical and virtual. You know, for the longest time, virtual really is obviously becoming a mainstay in our data centers. And but for the longest time, you know, as noted down here at the bottom of this graphic, is that most of our switches were physical in nature. With the advent of VMware and virtual standard virtual switches, distributed virtual switches, you know, the Nexus 1K from Cisco, things of that nature, we're getting very much into the switching capabilities that can be provided from a virtual perspective. These guys are carriers of protocols, and what I mean by that is that whether it's an IP switch or a fiber channel switch, is carrying a protocol that both the host and the array are speaking. So from an IP switch perspective, these are shared data center transports utilizing Ethernet. Most of us are familiar with Ethernet, right? I mean, most of us, well, it's funny, you know, nowadays most of us are running lab environments in our house that are just extraordinary. I mean, I know quite a few individuals within my organization that I work for that have lab environments that will compete with most corporation type lab environments. So it's just ridiculous the amount of capacity from a storage perspective, compute perspective, and even switching perspective that individuals have just for lab environments. Now the operational speeds of an IP switch are anywhere from 10 megabit, 100 megabit, 1 gigabit, all the way up to 10 gigabit, and of course it goes higher than that and will go higher than that. I see a lot of data centers, and I'm starting to see, and have been over the last not 10 years, but year, the move to 10 gigabit, and it's very much becoming a mainstay in our environment. And the reason is because it's becoming more adopted between the storage vendors and the server vendors, and it's also becoming less expensive. So we're seeing 10 gigabit more and more, which opens up a lot of opportunities from a switching perspective. Also, fiber channel switches. Now, I didn't talk about fiber channel over Ethernet. I didn't think it was warranted as in this slide, but you know, we're really looking at it from an IP perspective and a fiber channel switch perspective as it relates to storage. And the fiber channel switches are isolated data center transports that utilize FCP. So instead of Ethernet from an IP switch perspective, they're running the fiber channel protocol. And the operational speeds of fiber channel are anywhere between 1 gigabit to 4, 8, and 16 gigabit, which is creeping its way into data centers. What I see in a day-to-day basis is primarily 8 gigabit right now. But of course, over the next year, 2 years, we'll start to see 16 gigabit creep in as well. Saw a question. Let me save the questions to the end. All right, so now we'll get into storage arrays, which was kind of that last tier within the 3 core, and this is where your data lives. And if anybody knows anything about EMC, that was kind of their tagline. I believe it still is. This is where your data lives. So that's why I put it in here. And these can be either physical or virtual storage arrays can, and like anything nowadays, right? So, but from the VNX perspective, these are going to be physical arrays, and that's what we're looking at here at the bottom. Okay, so this is from the left to the right. We're seeing a VNX 5100, 5300, 55, 57, and 7500. So left to right, that's the models. We'll go over what each of these provide from a protocol perspective, from a disk count perspective, also some of the disk types in forthcoming slides. But this is kind of how the mid-range line of EMC arrays looks. All right, so what are some of the deciding factors? Storage arrays are often referred to and purchased based on performance and availability. Also, protocols delivered. So you'll see the two buckets here at the bottom. Those are the biggest two deciding factors that I see are the two buckets for determining what storage array that you want to bring into your environment. Of course, you know, I don't want to be remiss, but of course, cost is a huge factor. Allegiances, for instance, if you know, if your manager has an allegiance to NetApp and always has, and you know, maybe that's the route you've taken, or the same with EMC. Nothing wrong with that. It happens every day. Also expertise. So the individuals in your environment that are going to be administering these arrays, they have particular expertise, and therefore, you know, if all your expertise lies in the EMC world, bringing in a NetApp array may hinder the time that it takes to learn and deliver the resources that are needed within your environment. So expertise plays a factor in that deciding factor. From a performance and availability perspective, you're really looking at from an EMC storage line. You're really looking at it from an entry level, which would be the VNX-E, in the mid-range, which would be VNX and I would say Isilon, and then from the enterprise, you're looking at VMAX, so it's the metric line. And then from the protocols delivered, you're looking at blocks, so your FC, iSCSI, and FCOE protocols. And then from a file perspective, you're looking at NFS and CIFS. From a unified, that would be both block and file, and then object, that would be REST and SOAP protocols. So those are kind of the two buckets for the deciding factors. There's probably more. I've took the broadest deciding factors that I could, put them into two buckets. But certainly don't disregard the other three that I mentioned: cost, allegiances, and expertise as factors as well. So what mid-range arrays are available? We've already discussed that. There's 5 of them. First off is the VNX 5100. Now this is a block-only array. Okay, so this really gives you your low-cost entry point for those environments just requiring fiber channel connectivity. So it can't do NFS, it can't do CIFS, which I mentioned CIFS before. It's kind of the free version, so to speak, of SMB from Microsoft. So it allows you to do the whole sharing of files over the network. So your UNC paths to files are provided via CIFS capabilities on the VNX file side. But from a Microsoft perspective, if you're sharing out data from Microsoft server perspective, that's more of an SMB type functionality. NFS would be kind of the same thing, but its primary host connectivity would be from Linux or Unix-based systems. CIF would be more from Windows-based systems, just to explain a little bit about CIFs and NFS. As I mentioned, there are no file capabilities on the 5100, so you would certainly not buy this if you want to provide those. But you could, you know, if in the post VM world, you could throw a VM on a fiber channel volume and provide just traditional Windows server capabilities, file server capabilities. The 5100 has a max number of drives of 75. From a cache perspective, now all storage arrays in this day and age, and have for the longest time, have some level of caching capabilities on the front end, and that just means that, you know, cache on an array basically is DRAM. That means that it's very fast memory, so it's able to provide quick access, write and read access to incoming data from your host. So everything that a host writes to a storage array is coming in and landing in cache first. And then eventually over time, as that data warms or cools, it's eventually destaged to the back-end disk. So it's important to have enough cache to support incoming writes from your hosts. But, you know, on the smaller end of 5100, 8 gig may be enough for your environment. You'll see as we move through the different products, the different VNX models, that you'll see that the cache just begins to get larger and larger and larger. And also we'll begin to talk about secondary caching tiers, where you can actually utilize and expand into a secondary cache tier with flash drives. So all of these guys are fixed, you know, all the way from the 5100 up to the 7500 have a fixed amount of cache within them. But if you wanted to expand that, you would pretty much have to upgrade to a higher end array, or you could use a secondary cache tier under a feature called fast cache, which we'll talk about here in a little bit. From a port perspective, you have on the 5100 you have 8 front-end ports, usually abbreviated FE. and that's going to provide the fiber channel capabilities on the front end. So your host would be attaching to these fiber channel, or excuse me, they would be zoned to these front end fiber channel ports via the switches in place. So if you're at mid-level tier where you have those fiber channel switches, you'd have the host connect on basically one side, and you'd have the array connect on the other side, and via the magic of these fiber channel switches, you would do what's called zoning. And zoning is nothing more than pairing the host and its fiber channel connectivity with the array, so it can communicate with the array over this high-speed fiber channel switch. And then from there, you can do such things as LUN masking, where you can say, I want this particular host to see this particular LUN. And by the way, a LUN is a logical unit. It's a volume, basically, of storage that you're allocating to a host for capacity. But you're doing this LUN masking on the array itself, but the physical connectivity is coming from, is provided via the switches, but also is coming from the host perspective and is coming from the array perspective. That's under the ports section there. Also, there's two back-end buses, two back-end SAS buses, which is really the high-speed interconnect between the SPs, the storage processors, which I had mentioned earlier in that graphic. These are the big intelligent array controllers, essentially. So you have high-speed SAS buses between the SPs and the back-end disks. That's provided via two back-end SAS buses on the 5100. Just quickly, since we spent enough time on the 5100 here, the supported protocols for this is fiber channel only, as I mentioned. And then you'll see here at the bottom are the drive types. Now, I made mention of the disk and OE operating environment matrix. There's a lot of great information on EMC support website, support.emc.com. And it just happens to be that they're put into these matrix type documents. So this information that I provided down here was basically what I retrieved from the disk and OE matrix document, and I looked at my model. So in this document, you can look at your model array, so it'd be an X5100, and then I can see what disks are supported for that 5100. So very useful, especially across VNX, CX, product lines, ES, NS as well. Very, very good document to see what exactly what drives are supported. So from this perspective, and this will be the same across all the VNXs themselves. So they're supported 1, 2, 3 terabyte nearline SAS drives. Those are 7200 RPM drives. You'll see over there on the right, which I won't make mention to anymore, but these are different drive form factors, so 3.5 inch and 2.5 inch. You've also got, from a capacity perspective, you've got 300, 600 gig SAS drives from 10K and 15K RPM perspective. You've got a 900 gig 10K RPM drive, and then on the EFD side, which are enterprise flash drives, which have no mechanics in them, no moving parts. They are 100 gig and 200 gig options there. And I see the questions over there. Let me quickly get through these slides, and then I would love to answer all your questions. Just so I've got a couple more slides on the VNX itself, and then on the software suites. From a VNX 5300, the difference here is now you're stepping into the unified arena. So now you're moving from a block-only solution or a fiber channel-only solution into the ability to provide both CIFS and NFS capability. Okay. The number of drives doubles. So it moves up to 100. Actually, it does more than double. It goes up to 125, a little less than double. Excuse me. It goes up from 75 to 125, and then from a caching perspective, you're moving from 8 gigs of cache up to 16 gigs. So you're doubling there. From a front end perspective, so these are providing on the block side the block-based capability. So iSCSI fiber channel FCOE. That's moving from 8. From a fiber channel perspective on the 5100 up to 16. And then you still have 2 back-end buses. Then we get into the whole notion of what's called a data mover. So I mentioned mentioned a storage processor before, the big intelligent array controllers on the array. That would cover us from the block perspective. Now we move in and provide file level capabilities. So the ability to serve up both NFS and CIFS, and as a side note, MPFS and FTP. Those are different other protocols that the VNX 5300 can provide, but primarily NFS and CIFS providing those file level capabilities, but the data movers themselves are the servers providing that on the VNX itself. So these are separate entities from the storage processors, and on the 5300 you can do one or two. They're called X-blades, but they're referenced as data movers within the software itself. So you could have one or two from the file perspective, and each of those data movers has 6 gig of memory and 3 I/O slots. Now those I/O slots could be right out of the box. They're copper 1 gig interfaces. So you're providing file level capabilities from a data mover perspective over these 1 gig interfaces. Now you can also do 10 gig from a copper perspective and from a fiber perspective, but primarily what I see is 1 gig interfaces coming in on those data movers. And of course the protocols are expanded. You'll see that under supported protocols, and then the drive types are the exact same, and you'll see that across the entire line. Then we'll get into the 5500. This is the what I like to call the Unified Plus One. So it takes what the 5300 provided and builds on that. So you're expanding your drives up to 250. You're expanding your cache from the storage processor perspective. You're expanding your port count. Actually, fiber channels staying the same, but you're expanding your back-end buses, your SAS buses, so you can take it from 2 to 6. And this would be a high, what I mentioned in parentheses here, that would be a high bandwidth type option that you were providing in the 5500. And then the file-specific stuff, you're able to do 1, 2, or 3 data movers. And of course, right underneath that is all the memory capacity and I/O slot that you're able to do per blade. And then supported protocols and drive types is going to be the exact same for all the unified systems. So from the 5300 all the way up to the 7500, they're all unified capable. So you won't see the supported protocols or the drive types change in comparison across this line. 5700 is my Unified Plus 2. I'm building on the 5500. Now I'm scaling up to 500 drives, and I'm scaling my cache up to 36 gig, and now I'm taking my ports up from 16 to 24, and I'm increasing my back-end SAS bus. So really the 5700, and you'll see here in the 7500, you're now getting the enterprise. Now, even though EMC sometimes like to classify enterprise as just a metric, that, in my opinion and experience, the 5700 and 7500 are enterprise arrays. They're very capable of providing enterprise services to environments out there. From a file-specific perspective, we've now moving from 2, 3, and 4 X-blades that we can provide, and then of course supported and drive types are the same. And last but not least, here comes trouble, right? Here comes the 7500. It's the biggest, baddest of the mid-range arrays from EMC perspective. This guy can do 1,000 drives straight out of the box. Capable of doing that. From a cache perspective, anywhere from it can do it has a 48 gig option or a 96 gig option. Your ports now expand from a fiber channel perspective up to 32 ports, and then from a back-end SAS bus, which is hugely important, trust me, from 4 or 8. So having 8 back-end buses, which is that providing that highway between your storage processors and your back-end disks, is hugely important. The file-specific portion is you can go anywhere from 2 to 8 data movers, and of course you can see the memory and the I/O counts per blade have increased as well. And then supported protocols still right across every single line, except the 5100 is going to be the same drive types as well. That is the physicality of the mid-range line. Now we're going to get into the software suites. Okay, so we'll touch on those 5 software suites, which we'll go over and what's included in each of those. And then there's also the notion of these packs where you can bundle different suites into these packs of different suites and apply them to your array at a discount. Of course, that's the reason they do it. So the first one is Fast Suite, and we'll go over what each of these is. The next one is Security and Compliance Suite. Next one is the Local Protection Suite. Remote Protection Suite, and the Application Protection Suite. Now, prior to the VNX itself, which came out, VNX has been out since 2011. So, if it's anybody's guess when the next, the iteration to the VNX will come out, but we're here in 2013, and there tends to be a cycle with EMC as far as a major array release around the 2 to 3 year mark. So I would expect some release of the next generation, either VNX or something altogether different. I don't know, or at least I can't disclose here. But it should come out this year. Should come out next year. But it'll be kind of the next generation of VNX itself. But my point is that the software suites really became available on the VNX line. Prior to that, it was more, everything was kind of a la carte, which was very confusing. This has greatly simplified the buying process from our customers' perspectives. So as it pertains to software suites, the first one in line is the FAST suite. Now this is, what FAST stands for is Fully Automated Storage Tiering. This gives you the ability to basically tier data between different RAID types and different disk types. So everything within the EMC mid-range line from a VNX perspective is moved towards storage pools. And storage pools basically allow you to throw multiple disks into a single logical wrapper, and then within that logical wrapper, or that pool, per se, is that you're able to apply different efficiencies, whether it's a tiering perspective or whether you're doing virtual provisioning, you're doing thin provisioning, or you're providing caching capabilities or compression or dedupe, all the buzzwords out there. You're applying that at a pool level. And the reason you would use pools and where FAST comes into play is that it's inherently a lot easier to manage. Prior to storage pools, you had individual what's called RAID groups, and you were taking multiple disks, putting them into a RAID group that met your certain performance requirements from an application perspective. Then you would create another RAID group, just divvying out different RAID groups and creating those logical units or LUNs on top of those RAID groups. That became very cumbersome. I mean, in large environments, you could have hundreds of RAID groups on an array. With storage pools, you can collapse a lot of those RAID groups into multiple storage pools, or even a single storage pool if you wanted to, and then tier specific data between different RAID types that are needed or different disk types that are needed. And this is all done via the FAST capability. Enough about FAST. If I move on to Fast Cache, this is going to provide that secondary FAST or cache tier that I referred to earlier, where you're able to use your enterprise flash drives as a secondary cache tier that's measured in milliseconds. So it's not as fast as DRAM. DRAM is going to be your fastest, which is built into your storage processors. But it does give you expandable secondary caching where you can apply that to any LUN on your array. Now, one thing to note about fast cache is that when you're applying it to those pool LUNs that I mentioned earlier, or those pools, and you have LUNs within those pools, it's done at the pool level. When you're applying fast cache from a traditional RAID group, those RAID groups that I talked about earlier, and the LUNs that exist on those, you can do it on a per LUN basis. So there's some, there are some nuances with fast cache that you need to be aware of that I'm certainly, would be happy to answer after the presentation or even offline. Great technology, goes very well with fast, so keep that in mind if you do move down the VNX path. Analyzer provides basically performance monitoring to your array. Certainly, I would say Analyzer is one that is under the radar for most people. They get it when they buy the FAST suite, but it's rarely used except in situations where you have a performance issue. But I like to use Analyzer for baselining the array itself, and then you have a good basis for how your array is going to perform over time. And then when that 3-year cycle ends, for most people, then you know what to prepare for in your next gen VNX or whatever it is. Quality of Service Manager is just what you would think it would be. It gives you the ability to apply QoS type services to LUNs within your array itself. and other features within the array as well. The bottom box here, as I mentioned earlier, you have these packs. So you have these two packs, the total efficiency and total protection pack. The check mark implies that the fast suite is part of that pack. No check mark implies that it's not. So in this case, the fast suite is a part of the total efficiency pack, and it is also available a la carte. Next is the security and compliance suite. This is one that have limited exposure to, just because, and I make a funny about this because it's, I think most people know they need antivirus. They know they need, file level retention potentially. They know they need host encryption. They know they need a lot of the stuff that this compliance, security and compliance suite provides. But to me, security will never get implemented in the manner that it should be until it becomes, a lot easier to implement, and it's not as intrusive as it is today. So I haven't seen the security and compliance suite utilized a lot. I have been exposed to some of the antivirus capabilities, which is what the event enabler, that top bullet point, provides. So it provides you, since this is on the NAS side, this is on the file side of the VNX, it allows you to integrate with third-party antivirus solutions. So you can provide antivirus capabilities on a basically OS-less type system, because NAS is OS, it's not running Windows or anything like that. So that's what an event enabler provides. Also quota management, so user quotas, group quotas, tree quotas, which would be kind of hey, I want this particular folder to have 150 gigs of capacity or quota space, and that's it. So there are hard boundaries on each side. And then auditing capabilities, also FLR, which is file level retention. This is more of a write once, read many type capability, where it's able to lock files for a specific amount of time. And then host encryption. Security and compliance suite is part of the total efficiency pack and a la carte. Local protection suite, and you'll see here the next one, the remote protection suite, are really areas that I'm passionate about, namely because protection of data that exists on there is very important, and moving that data is becoming very important as well. So you'll see that as at the very bottom here, recover point is one that's usually hugely passionate in my book, namely because it really is kind of the next generation of replication products, and has been for quite some time now. The other three products are all local, actually they're all local protection, but we'll see that recover point also has a remote option, which is why I mentioned that. But VNX Snapshot, SnapView, SnapSure, those are all local type operations where you're able to checkpoint or snapshot your data to provide local rollback capabilities. It is local to the VNX itself. You can't take a snapshot. It is specific to that array. So it requires that the source volume is still in place, still existent. So if you completely deleted the one that had snapshots on it, snapshots would be pretty much useless. VNX snapshots have been introduced from a pool perspective, meaning you can only take VNX snapshots on a storage pool perspective from the block side of the VNX. SnapView has been around for years. It provides snapshotting and cloning capabilities. That applies both to storage pools and traditional array groups. And then SnapSure gives you the checkpointing or snapshotting capability from the file level perspective. Recover point, as I mentioned, it is a local protection option as well. It requires, for all intents and purposes, it requires physical appliances outside of your array. There's a virtual option. And it allows you to do continuous point-in-time captures of your production volumes. Very cool technology. The local protection suite is part of the total efficiency pack and a la carte. Remote protection, two things that were added here outside of recover point are replicator. So VNX replicator, this will give you the capability to remotely or locally replicate. It can do that as well. Your file data, so your CIFS and NFS data, you would use VNX replicator. Back to the block side, if you wanted to, you could use mirror view, either async or sync. Like I said, most R&D and most focus within EMC is put on recover point at this point, but mirror view's been around for years. It's a mirroring technology. It does work great. Not nearly as robust as recover point, but you do have that option because it is inherently cheaper than recover point. Remote Protection Suite is part of the Total Efficiency and Protection packs and a la carte. And last but not least is the Application Protection Suite. So this encompasses Replication Manager, which, how I like to explain Replication Manager is it doesn't really provide any new capabilities. What it does is allows for automation and orchestration of data protection methods on the VNX itself. So it integrates with, with your VNX snapshots and your snap views and your snap shores and recover point, and it's able to take, specifically maybe an application point in time. So you've taken your application and you want to get something that's beyond crash consistent, which means when you recover an application, it is as good as it would be as if you pulled the power cable on it. If you wanted to do application quiescing and get these consistent views of your application, you would use something like Replication Manager to provide that automation and that flushing of the data buffers on the host itself to get that application consistent view within your replication products. It's an orchestration product. I mean, that's what it does. So it doesn't, outside of this, you could certainly do the same thing Replication Manager is doing for you, but you would have to use homegrown scripts and things of that nature. And last but not least, Data Protection Advisor, DPA as it's called, is a monitoring, analysis, reporting, and alerting product. It sits outside of the array itself and integrates with your EMC products to provide kind of those 4 core features. Trending, if you want to do trending as well, it's Data Protection Advisor is your product. Application Protection Suite is applied or is available in the Total Efficiency and Total Protection Suite, or packs, excuse me, and a la carte. And with that, about 45 minutes in, I am done with the actual PowerPoint presentation. I would love to answer any questions you guys have. I know some stuff have come through here over on the right. Just before I get to those, thank you so much for the support with the course and with this webinar, and thank you for letting me explain kind of what the course is going to present and letting you guys in on the EMC mid-range world. You can reach me at jkelly@varrow.com. You can meet me on Twitter at virtualtacit, and I do a little bit of blogging over at blog.virtualtacit.com. Okay, so I'll try to answer these questions. I'm sure I'm going to butcher your name, Redawayne. What is application? So please, what is application mapping? What is a real world example? This is touched on in the course. It's really about what, like for instance, like Exchange. It has certain ways that it writes data to disks. So from an Exchange perspective, I believe it writes in 8K chunks. And then you have other applications that write in particular chunks as well. So if you know how an application writes to disk, you can better formulate and design the backend storage that it needs to accompany the application. Also, there's a huge amount, obviously, of I/O requirements, so input/output. So applications require a certain amount. You'll probably see this from a lot of storage vendors where they require a certain amount of I/O. Microsoft may say, for Exchange, I need 5,000 I/Os. I need the storage capable of supporting 5,000 I/Os. You can take that information, although it may be bloated from that perspective, and begin to do more. You can take that information and begin to build out what you need from an array perspective, from a performance perspective. One thing I did want to mention on application mapping as well in performance, performance. We're hoping to do another course that's more performance driven. There are, I know what I know about performance, and there's a lot of individuals out there, especially within the company that I work for, that have more performance type experience. So we're hoping that we can take that and bring it to Train Signal and provide that information so that you can take, the information that will be presented in that course, and you can relate it to your environment and what you need to provide from an array perspective. What is most cheaper storage? I'm not sure. I'm not entirely sure how to answer that. I'll try to answer it. Shivaji, if you want to maybe expand on that question a bit. But if I'm understanding what you're asking, well, let me just assume I know what you're asking. All right? So from a VNX, that is their mid-range line, right? So that sits between, your entry-level arrays, and that sits, it sits right in the middle between your higher-end arrays. So on the lower level, if you want to go, lower capabilities, lower performance capabilities, if you wanted to go lower than a VNX, you would go to a VNXE, and they have a couple models there that you can choose from. If you wanted to go higher, you would move up to the VMAX itself. If you wanted to move just, if you we're still talking in the confines of the VNX itself, if you wanted to move to cheaper storage within the VNX, you would usually look at nearline SAS. So this would be the SATA equivalent. If you're familiar with older arrays or other arrays, they may be using SATA. These are basically different interfaces for different types of drives. So from a cheaper perspective, you could certainly, load your VNX with nearline SAS. That would be a cheaper alternative, although you would pay the price on performance because it's not built for performance like SAS drives are and like EFDs are. Are we going to receive a copy of this? Are we going to receive a copy of this recording session? Yes, it should be on TrainSignal's site. I'll let the TrainSignal guys answer on that. But as far as I know, like all the webinars, they will become available at some point on their site. If SAN has 8 buses, how are the buses connected to a 15-drive RAID 5 line? Can this line communicate across multiple buses? No, it cannot. Typically, the drives are part of a bus, so they communicate across that bus. So they're not communicating across all 8 buses, but the SPs themselves obviously are privy to all 8 buses. I hope that answers your question, Dave. EMC training course from TrainSignal alone is enough to prepare for the entry-level exam. Absolutely not. Absolutely not. This was about a 4-hour course that we did, 4 to 6 hours, and it touches on all the main topics that I think are applicable to the exam itself, the entry-level exam from EMC. But if you one of the things that I put in the next step slides, which was the last lesson for the course itself, is to actually go out and buy this book called Information Storage Management V2 from EMC Education, and it has a wealth of knowledge that will completely and utterly prepare you for this exam. If I were to prepare a light course based on that book, it would be hours and hours and hours and hours. So it just wasn't appropriate. It was more of, I wanted to introduce these concepts with a kind of a first essentials course and then move on from there. So that's TrainSignal's intent. That's my intent as well, is to take this as a building block for other storage courses. And it's already in the works. I know TrainSignal has reached out to individuals. I've discussed other courses that I want to do with TrainSignal as well. So it's coming, and it's not even. And I'm only speaking from the EMC perspective, but I'm sure they'll provide other vendors as well as it's applicable. But EMC is just because of their sheer size is really the easiest target, because it is a very large company. It is in a lot of environments. So that seemed like a good starting point from both our perspectives. Let's see. Thanks, Luis. How do practice labs for EMC? How to do practice labs for EMC storage? That's an interesting question. They do have simulators, which I don't know if they're available to potential EMC customers. Obviously, they're available to partners. So they do have simulators. They also have the VNX simulator, which may be available to everybody, I believe. I know Chad Takach has put some information on his site. There's a lot of information actually out there on the VNX simulator that you can get and you can run it on Workstation, Fusion. I believe you can even put it on ESXi and run it from there. But it gives you kind of a glimpse into Unisphere, which you'll notice. I just wanted to mention. You'll notice this webinar we didn't do any demos, and that's kind of how the course is structured. I mean, there are some demos within the course itself. I don't want to scare you away because I know, trust me, I would love to be doing more demos, but we knew that this Storage Essentials course was going to be very rich and heavy in fundamentals. And how do you demonstrate fiber channel? I mean, I could jump on a fiber channel switch and I could maybe zone something or create an alias, but it's very hard to demonstrate that. So a lot of my demonstrations are within Unisphere, which is the product you use, the interface you use to manage a VNX. So a lot of the stuff is in there, and you can certainly apply that to to things that you're learning in your environment, whether you have an EMC array or not. But if you don't have one, you could get this simulator, and it does give you the ability to run Unisphere against a simulated VNX. Also, if you are a partner, I'm not sure if any partners are on the call or not, but there is obviously VLabs, EMC VLabs, which is basically a cloud-provided lab environment for partners. I'm hoping you're seeing VMware do this with a lot of products, which is great. Great idea, very beneficial. Not only partners, but customers as well. I'm hoping EMC, as far as I know, they haven't released VLabs to customers, but I'm hoping at some point they'll do that as well. I purchased a VNX E3150. That's an entry level. Yes, 3150 is seen as entry level from just a tier perspective. It still provides a lot of great capabilities. Still a great array. But in comparison to the VNX, it is below it. I mean, it is entry level from a cost perspective and the capabilities it provides, and the availability that it provides. So I don't want to diminish the fact that the VNX-E is not a great array. It is, but it is entry level in comparison. What are the basic knowledge requirements to get to the EMC storage world? What are the basic knowledge requirements to get to the EMC storage world? Well, I would promote this course, right? I mean, if you're a subscriber to Train Signal, which you should be, there's tons of great information out there. And now with the subscription service, you can get access to all of that. Basic knowledge, it will be included in the EMC Storage Essentials course. Outside of that, I would start with that Information Storage Management V2 book from EMC Education. That starts from soup to nuts. I mean, all the way down to the components of a mechanical hard drive, all the way up to talking about a lot of EMC's product line. So it'll go in some of the Isilon, Avamar, Data Domain, VNX, SIM. I mean, talk about everything. I mean, it's really an all-encompassing book. So that would be a good place to start outside of this course. How to experience or have hands-on labs for such storage products usually available for data centers? Is it possible for an individual lab, and what could be prerequisites? From how to experience or have hands-on. Yeah, I kind of mentioned that earlier. I don't believe EMC has a true lab environment like VLabs has provided to customers, that they can open it up and get you access to to the different interfaces and the different products. There is that VNX simulator, which you can download, I believe, straight from support.emc.com. So if you are a customer today, you can go to the support website and you should be able to see the option to download that simulator for the VNX. Outside of that, from an EMC perspective, that would be tough. Obviously, there's a lot of other open source type storage products that you could get experience with, but assuming since you're on this EMC Storage Essentials call or webinar, that's about the best I can give you from a lab perspective and SIM perspective. Darshan? Will we be getting any practical training in VNX, VMAX, VPlex, or any other storage trainings? Yes. Yes, we will, definitely. Train Signal is I think I can mention this one. I'm working on a EMC Recover Point one right now. There's also talks for some of those other products as well. So yes, definitely, this is about the tip of the iceberg. And certainly, if there's anything that you guys would like to see from an EMC perspective, and even EMC perspective and how it maybe integrates with something else, and I'm kind of leaving that question where, you know, EMC is such a huge vendor, has a huge footprint in data centers that, and so does VMware. So what about something in particular about how those two integrate? You know, I think that would be a good approach as well. And there's so many options. I mean, there's so many options that could take place from a course perspective in regards to not only EMC storage but other vendors as well, and how they integrate with things within your data center. So look for a lot more training in that regards. Thanks, Sepwan. I'm butchering these names. I apologize. Tools to test the storage performance. From an EMC perspective, you could use, you know, if you wanted to monitor the storage performance, you've got a couple different options. You've got VNX reporting and monitoring, or monitoring and reporting. You've also got Data Protection Advisor, which I talked about a little bit, and you've got Unisphere Analyzer. Those are all tools that you can use to monitor the performance. If you're wanting to test performance, meaning you want to generate I/O to a LUN to make sure that the array is capable of performing the way that you intended, there are a number of products out there. I mean, Iometer is probably a big one. There's a number of there's a couple from Microsoft that you could use to simulate application type I/O to storage to test the performance. You know, take your pick. But those are a couple that I think of first off. You're welcome. All right, that's all I got for questions.